Hi, today we're going to do a center of gravity problem. We have kind of a makeshift operation here, but this is the problem. A 6-meter long plank has uniform mass of 90 kilograms. I've drawn the plank here. The plank is placed with its center of gravity exactly halfway between two concrete supports, which I've drawn here. And there's the center of gravity exactly halfway in between them. The two supports are 1.5 meters apart. And there's a person standing on this edge of the plank. And the question is, what's the maximum mass this person can have before the plank tips over? So in other words, his center of gravity has to be between these two concrete supports. The more this person weighs, or the larger his mass, the more the center of gravity of the plank person together will move to the right. The maximum distance it can move to the right is right over this concrete support that's on the right. So I drew the picture here. We have the 6-meter long plank. There's the person at exactly 6 meters. The left-hand side of the plank would be at 0 meters. The person's center of gravity would be at 3 meters. And since these two supports are 1.5 meters apart, they're each 0.75 meters from the center of gravity. Okay, so we know from earlier chapters that to find the center of mass, we sum up each mass times its distance from the origin, and then we divide that by the total mass of the system. Now, today we're asking about center of gravity. Now, in reality, the center of gravity and the center of mass are exactly the same thing, unless you're talking about a really tall object. And the reason for that is, to find the center of gravity, you sum up each object's mass times the strength of the gravitational field at that point, times its distance from the origin, and then divide by the total mass times the gravitational field strength. So unless you're talking about a really tall object, a really tall tower, a really tall building, where the gravitational field is stronger at the bottom than it is at the top, the center of mass and the center of gravity are in exactly the same place. Now, for really tall buildings, there's about a 2 centimeter difference between the center of mass and center of gravity, because the same mass at the bottom of a tall building will actually weigh a little bit more than the mass at the top of the building. That'll pull the center of gravity down a little bit below where the center of mass is. So we can actually, for this problem, we can use these interchangeably. And actually, since the gravitational field strength is going to be the same everywhere, we can just leave it out. So I want to find the center of gravity for the plank and the person together. So I'm going to take the plank's mass times the distance from the origin to the center of gravity of the plank, plus the person's mass, which I'm calling m, times his distance from the origin, which is 6 meters. And then I'm going to divide by the total mass, which is the mass of the plank plus the mass of the person. And that can't be any further than 3.75 meters from the origin. Once it gets past that point, the plank tips. So I have here an equation with one unknown, that's m. Now I rewrote the equation down here without the units, because I noticed I was using m for the person's mass, and then I was using 6m as in meters. So I left out the units here. So 270 plus 6m over 90 plus m equals 3.75. You go through the algebra, and we solve for m of 30 kilograms. So if this person has a mass over 30 kilograms, he's not safe here. The plank's going to tip. If his mass is 30 kilograms or less, the plank will support him.